Yeah, hello. I'm Oliver. I'm Chief Data Scientist and co-founder of useR. And today I want to talk about R beyond prototyping and share some best practices of our projects. So what are the challenges in prototyping and if you have R in a critical enterprise environment? There are a couple of challenges regarding redundancy and backups and stuff like that. But from my point of view, the most important issue is about change. So if the world wouldn't change, we wouldn't have a problem. But as the world does change, we need to deal with that somehow. So what type of changes do we have? We can have changes in the operational systems. We can get new versions on that. We can have changes in R itself, updates in R. We can have changes in the packages and the dependencies. We can have changes in the scripts, in the code that the data scientists typically develop. And we can have changes in the data. So data changes are not that much of a problem. But if the changes are in the structure of the data, then we get problems. So I don't want to focus on operational systems, and I also don't want to focus on the interpreter, so we will stick with packages, the dependencies, and scripts, and en passant regarding the structure of the data as well. Okay, if we look on changes, we have on the one side, in a productive environment, we have the data scientist, and on the other side, we have the IT operator, and they have two completely different perspectives on changes. When the data scientist sees opportunity, the IT operator usually sees risk. The data scientist is pretty much into agility, whereas the IT operator focuses on stability. Data scientist wants freedom, and IT operators want rules. So it's not wise to go only with one side of it, but it makes sense to somehow combine those two perspectives. And how can you do that? Okay, it's a couple of components that play. When they play together, then you have a good chance to bring R also in the productive environment. First of all is version control. I assume that everybody uses version control now, but it's not only version control, it's also a branching strategy. It's not about the tools, it's about the strategy, how you use the tools. Then you need a staging architecture. So not only one server, you will typically have three different types of servers, a production server, a test server, and a development server, so you can kind of grow your analytics horizontally. Then you could add like continuous integration for automated testing. This is especially important if you switch from one server to another. And you need some way of how to deal with package management. There are two options available, Packrat from RStudio for decentralized package management and Minikran for centralized package management. Okay, so let's start with version control and staging. So why do you want to do version control at all? I mean, I guess most of you do it, but what's the advantages of that? You can track your changes, you can restore versions, older versions, you can see the differences between versions, you can simultaneously develop with many developers, you can simultaneously manage several versions of your code, and that's also important, you can enforce programming and quality standards by using versioning. So how could it look like? Okay, so I'm talking about staging architecture and versioning at the same time. On the left-hand side, you see the architecture with three different servers, production, test, and development server. And then we have two branches, the master and the development branch, and these are called the main branches. And they grew kind of vertically over the systems, and we also have changes horizontally over time from left to right. So we start with our application, whatever it is, and then we want to add a new feature, say a Markdown report. Then we open up a new branch, and this branch lives also on the development server. We add another feature, or we kind of improve our feature, and then we add another feature. So now you see that no problem at all that many developers can work on several versions at a time. Now we have another progress in the Markdown report, and then finally we say, well, that's good enough now. We want to merge it to the development branch. And we close this feature branch after we have merged. Okay, make some progress in this one. And now we say, okay, our development version is good enough. We want to put it on our live system. But before we do that, we put it on the test system, as you see on the blue indication. And that's the release branch 0.1.00. And at this point, we can do some user tests. We do a couple of tests there, but we also do user tests. For example, if you have a Shiny application, you want to do user tests, or if you have an API and your results are consumed indirectly by other applications, then you can do a user test. There, they will look for bugs, and they will find some. You need to fix them. And once the users are happy, you can put it on the master branch, and this can go to the production line. Okay, next step is some improvement in the cluster analysis down there. We open up a new feature branch, and now this is an interesting step because, as you see, the improvement of the cluster analysis goes in parallel with some other developments there, and when you merge now, it can happen that you can get conflicts because you have in parallel developments, and you need to solve that, obviously. Okay. We make some more progress, and then we get a bug in our live system. That should not happen, but it just does happen. So what we do there, we open up a new branch, also on the test system, just for fixing this particular bug. We do some bug fixings here, and then we bring it back not only to the live system, but also to the development system, because we won't make sure that this bug will never occur again, of course. Okay. And now the process goes on, and here we see a new release version, which we're going to release there. So now, in the end, we have 5 different branches, 2 main branches, the green master branch and the red development branch, and we have 3 supporting branches, the feature branches down there, the release branch in the middle, and the hotfix branch on top. Okay, and while we're switching over the versions, we want to make sure that everything runs good when we move from one branch to another one. And this can be done by continuous integration. And it goes like so. We have our data science teams, and they have their local branches on their systems. I didn't mention that yet, but as you probably all use Git, you will probably know that. What we saw on the slide before is this remote repository where all the branches are located. And once this repository or you can add the continuous integration server into this, and there's a trigger that checks when there's a new version on the master branch, for example. And before it gets actually pushed there, it starts a continuous integration pipeline. And that could go like this. You kind of clean up a working directory, you copy the branch that you want to push to the repository to the working directory. You start an R session, and then you do tests, different types of tests. Unit testing for the functions, integration testing for the complete script or a combination of functional testing to check whether the input and the output of the complete stuff is fine, and performance testing probably also to make sure that everything is still as fast as you expected it to be. If you are building packages, then you would build a package here as well. It's not necessary, of course. It's a kind of optional step. And then you get a feedback to the repository. If everything is good, then the branch will actually be deployed. And finally, you could deploy the new versions also on the systems as well. So that's the way, with continuous integration, you can make sure that kind of your code is running smoothly even though you updated things. So the last component is package management, and there are several options of how you can do it. This is a standard way of package management. On the left-hand side, you see cron or any other repository living in the internet. Then we have there 2 computers, could be servers or client computers, doesn't really matter. And they directly consume from cron. And if you install packages, then you install them directly there. So if a user uses different versions of then it goes to several, you have a different version of the packages available. Okay, and if you now work with your projects, all is good as long as kind of the people who develop the project uses their own projects. But if you switch, if other developers needs to develop additional features, then you might get a problem because you have different versions of the packages available. I assume that everybody knows this issue, right? Okay, so what can you do? There are 2 options available. Both are reasonable. Decentralized packages with packret. That goes like so. On the left-hand side, we have our system. It could be the production, test, and development system. In principle, it's all the same here. And now we don't install the packages to the to R, but we install it to the projects. The versions are still different, but as the packages live directly at the projects and close to the scripts, we don't have a problem, even though if other users uses or develops some further on the project, because the packages are closely related to the packages. Well, that will work. And there's another option, and that's centralized package management. You can do this with Minikran. And here we get some more components into the process, and that is, I call it an LRAN, local repository, and that's a good thing because now you're not relating directly to the internet. You can copy to a repository that has no access to the internet. And we have a new role, and that is the data science administrator, and this administrator is somewhere in between the data scientist and the IT operator, and that's a good thing to have this role which can kind of mix between those things. Okay, now we put the packages from CRAN to the local repository, and from there we install it. Okay, and as you see, or I don't know if you see really, but the versions are all the same, the package versions. So now we can use this. Oh, one thing I forgot to mention is really wise that everybody uses the same R version. So you should not work in a production environment with different versions of R. Okay, and now on the left side on LRAN, there's ggplot2, and this is not yet in the project 2, so we just added there, and so we can really easily work with different projects with this strategy. So, okay, centralized and decentralized package management is both reasonable, but if we look at updates, what do we do then? Just assume that there's a critical update on ggplot. I know that this is kind of an unrealistic scenario, but let's just imagine. Okay, that's a critical security update. So how would you do that? If you look here in the decentralized way, all of the projects need to update the ggplot package. Even though, so you make sure who does really take care on that, who will do that. So there's no role for that. So that can be pretty tricky, especially if you have many projects. In the LRAN case, or the centralized package management case, it goes like so that you add another local repository, that's the check repository. You add a role on the servers. So the data science admin gets their own user access only on the test system, and the data science admin installs packages from the check LRAN. Okay, so now ggplot2.3 goes to the check LRAN, and then it moves over to this user, and then the data science admin checks all the existing projects whether they still work with this new version of the package. And if there's any problem, then data science admin will get in contact with the project developers and fix the issue. And if there's no problem, which is in the majority of the cases the case, then we don't have anything to do. If everything is checked, we can move it over to LRAN and spread it out from there to the regular package versions, and then we have updated our system. Okay, so to sum it up, with these components, version control, staging, and package management, we got components that you can use for production environments, and if they play together, then you got a really good chance to have a stable system also in a productive environment. Okay, so that's all I have to say. Thanks for your attention, and if you have any questions.
Thank you very much. We still have some time for the questions. Does anybody have a question?
Okay, no questions? Okay, thanks.
Thank you very much.